Hello everyone. In this video I'm going to take the game script from part 2 and add the code to animate my player. That way he doesn't just stand there sliding around the map, which doesn't really make a whole lot of sense. First thing I need to do is get the graphics I need to animate Mario. That's pretty easy to do since all I need is a Super Mario Bros. Sprite sheet. A sprite sheet is an image that contains all the frames of animation for a sprite in a video game. Sprite sheets are really easy to find online, so it didn't take me long to find this one. Once I have the graphics, I need to find a way to use them in my game. I could use MS Paint to cut out the frames of animation and save them as separate files. That would certainly work, but I'm not going to do that. What I'm going to do is load the entire sprite sheet into my game and then use Blit to copy the frames on the sheet to separate surfaces. I can load the sprite sheet the same way I would load any image by using pygame.image.load. The argument is of course the path to my sprite sheet. Then I'll create a surface that's 16 by 32 since that's the size of each frame on the sheet. The sprite sheet is partially transparent, so if I want the transparency to show through, I need to blit it to a transparent surface. So I added this pygame.src alpha argument to say that this surface is going to be transparent. Then I'll call blit on the surface and blit the sprite sheet at a set of x and y coordinate points. Those coordinate points are going to be the position of a single frame of animation on the sheet. I can find the position of a single frame on the sprite sheet by using MS Paint. All I have to do is put the cursor in the upper left-hand corner of the frame I want to use. In the lower right-hand corner of the window is a set of x and y coordinate points. This frame is at position 30, 52, so to copy this frame I would blit the sprite sheet at -30, -52. The upper left-hand corner of the character surface is considered to be 0, 0. So blitting the sprite sheet at -30, -52 will place the sprite sheet 30 pixels left of that corner and 52 pixels above that corner, which means point 3052 will now be in that corner. So now I'll have a 16 by 32 pixel transparent surface that has this frame on it. If I scale the surface and give it a unique name, I'll now have that frame available as a surface that I can use in my script. Using this code, all I need to do to import a frame of animation from the sprite sheet is to find the frame's x and y coordinates and give it a name. MS Paint would definitely work for that, but I decided to make a small utility script to get the coordinates. Rather than finding the coordinates with Paint to position the sprite sheet, the utility allows me to position the sprite sheet to find the coordinates, which is definitely a lot easier. In my utility script, I can load the sprite sheet as a surface, and the utility will draw the sprite sheet surface to the screen at 0, 0. I then have a set of arrow keys that can move the sprite sheet's x and y coordinates. If I move the frame I want to the upper left-hand corner of the screen, the sprite sheet will be at the coordinate points I need to blit this frame to the character surface. Although I wouldn't want my character surface to be this big, so I have another set of arrows that can adjust the size of the surface I want to create from the frame. Once I have the frame I want in the right position and have the character surface set to the right size, all I have to do is hit the spacebar and the utility will ask me for the last thing the frame needs, which is a name. After I name the frame of animation, I can hit enter and then move on to the next one. Lining up all the frames I want and naming them only takes a few seconds. When I'm done, all I have to do is open the utility's output file in the main folder. All the code I need has been generated for me, so all I have to do is copy it to my game script and I can use the frames to animate my player. Currently my player loads an image of Mario standing from the graphics folder, but now I can just use the surface I created from the sprite sheet. So I'll set self.image to Mario stand 1, and when I run the script, Mario looks exactly the same, but that's a good thing because it means the frame I made looks the way it's supposed to. I can load any of the frames I created from the sprite sheet to the player's self.image property to change which frame Mario uses when the game starts, but if I want to animate Mario, I need to be able to change Mario's self.image property while the game is running. So the first thing I'm going to do is create a small function that I can call to change the player's self.image property to any image I want. I'm just going to call the function updateCharacter and have it accept andsurf as an argument. I'm going to say that andsurf stands for animation surface, since I'm expecting the argument to be a surface that I'm going to use to animate the player with. Then the function will set the player's self.image property to that surface. If I call this function at the end of the player's update function with whatever frame I want to use as an argument, I can run the script and see that it works. The player object doesn't have the same image property it started out with. Instead, it has the image property set by updateCharacter, which is updating the player's image on every update because it's run in the player's update function. Of course, updating the player's image with the same frame every update won't result in animation. What we want to do is change the frame based on certain conditions. Rather than writing out all the conditions at the end of the update function, I'm going to create a new function to write the conditions in and run that function at the end of the update function. So I'll call the function animate and start writing some conditions. I'll start with the easiest one, which would be whether or not the player is moving. If self.xval is greater than 0, or if it's less than 0, the player is moving, so I'll call updateCharacter with the first frame of Mario walking. Else, the player is not moving, so I'll call updateCharacter with the frame of Mario standing. Now when I run the script, Mario can change between frames depending on whether he's moving or not. This is a good start to animating my player, but I think it would help if he could face the direction he's moving in. I could use xval to know which direction the player should be facing when he's moving, but it won't tell me anything if the player is not moving. If the player is not moving, he should be facing in whatever direction he was moving last. The player object doesn't have any properties that can tell me that, so I'll have to create the property myself, and I'm going to call it faceRight, since this property is going to tell me whether or not the player is facing right. If the player is facing right, which he appears to be when I start the script, faceRight is equal to true. Then I'll go down to my left and right if statements and say that pressing left will set faceRight to false, and right will set it to true. So the player will always be facing the direction he was last moving in. Then I'll go down to the updateCharacter function and say if the player is not facing right, use Pygame.transform.flip to flip the andsurf image vertically. The first argument is andsurf, which is the surface I'm going to flip. The first bool argument is whether or not I'm flipping the image vertically, and the second bool is whether or not I'm flipping it horizontally. The result is saved to andsurf, so if the player was facing left and the image was flipped, it will be set to the player's image property. Running the script with the faceRight property set will allow Mario to face in the direction he's moving, although he doesn't really appear to be walking while he's moving, so next I'll add the animation for the walk loop. The walk loop is a series of 3 frames that I'll flip through as the player is updating, so the first thing I have to do is create a way to track the player's updates. So in the player class's init function, I'll add this self.counter variable. This variable will count the updates. Below the animate function, I'll add a new function called walkLoop that will advance the counter. I'll have the animate function run the walkLoop function to advance the counter whenever the player is moving. Then I'll use some if statements to change the player's image based on how many updates have been counted. If the player is moving and has counted 5 updates, it will set the player's image to the first frame in the walk loop. After it counts 10 updates while moving, it will set the second frame of the loop, and when it counts 15 updates, it will set the last frame of the loop and reset the counter to start counting from 0 again. When I run the script, Mario does flip through the images in the loop while he's moving, but it doesn't look right at all, which is probably due to the frames on the sprite sheet not being in the correct order. Reversing the order of the frames should solve the problem. And it does. So now Mario appears to be walking when he moves left and right. Although Mario will still appear to be walking when he moves left and right even if he's in the air, which of course is not right. So I need to add a condition to the animate function to use a different frame for when Mario is in the air. At first you might think there already is a property for whether or not Mario is in the air, and it's called self.onGround. So all I have to do is say if the player is not on the ground, use the frame of Mario jumping. That sounds like it should work, but it won't. The reason for that is when the player lands on a platform, self.onGround will equal true, and y velocity will be 0. On the next update, self.ground will be set to false before the y collisions, and the y velocity will still be 0, so self.onGround won't be set to true, even though the player is still standing on the platform. On the update after that, since self.onGround is false, the y velocity will increase 0.3 pixels, but there is no such thing as 0.3 pixels, so adding 0.3 to the player's rec.top property won't do anything. The rec.top property won't be increased until the y velocity is at least 1 pixel. So since the player isn't moved, it doesn't collide with the platform because the player and the platform aren't overlapping, so self.onGround will still equal false. On the next update, another 0.3 is added to the y velocity, which would make it 0.6. Still not a full pixel, so the player still won't move, and self.onGround will still equal false, and it won't equal true again until the y velocity is at least 1 pixel, which counting by 0.3, the y velocity will be at least 1 pixel when it reaches 1.2. Then the player will move down 1 pixel, collide with the platform, and will be considered on the ground again. So since the self.onGround property works for moving the player around, but doesn't necessarily tell me whether the player is actually in the air or not, I'm just going to create a new property for measuring the y velocity, and have that tell me whether the player is in the air. I'm just going to call it self.airborne and set it to true, since the player does start in the air, so why not? Then in the update function, I'm going to test the y velocity to see if it's less than 0. Any negative velocity would be moving the player up, such as when the player is jumping, so that's definitely in the air. But the player can also be in the air without jumping if he falls off a platform. In that case, the player would be moving down and have a positive y velocity. Since any velocity less than 1.2 that isn't negative won't move the player at all, I'm only looking for velocities greater than 1.2, which would mean the player is actually falling. So if either one of these conditions return true, then self.airborne will equal true. The player is either jumping or falling. Now that self.airborne can be set to true, it needs to be set to false at some point, which I'll say should happen when the player lands on a platform. Now I can go to my animate function and say, if airborne, use the frame of Mario jumping. So now that I've done all that, I can run the script and Mario will have the frame of him jumping while he's in the air. Whether he's falling or jumping doesn't matter, since Mario uses the same frame for both cases. And now that Mario has an animation for every state he can be in, he is now a fully animated character. He appears to be walking when he's moving, appears to jump when he's in the air, and will stand in whatever direction he was last moving in if he's just standing there. He can, of course, be programmed to do a few other things, since there were several frames of animation on the sprite sheet that I didn't use, such as him ducking, turning around, and swimming. But I'm not really concerned about what he can do beyond being fully animated. I would rather focus on adding a bit more excitement to this big empty level by adding some enemies to the game. So I will do that in the next video. I hope you enjoyed this tutorial, and thanks for watching.